Hi students, let us start the chapter atoms. This chapter is from class 12th chapter, and in this chapter we are going to cover the whole chapter in 3 shots. In the first shot we are going towards the concepts in this chapter like atoms, different atom models like Thomson's model of atom, Rutherford's model of atom, and Bohr's model of atom, and also we are going to go through Rutherford's atom model and the basic assumptions that make it, and what were the experiments that led him to reach at such inferences, and what were Rutherford's experimental arrangements, what were the drawbacks of the model, and what about the distance of closest approach when alpha particles reach the target atoms, the target things, then where does it return from, what is the distance of closest approach, and we shall also talk about impact parameters and the quantization, then the basic postulates of Bohr's model like nuclear concept, quantum condition, stationary orbits, and frequency conditions. Then we shall move towards the theme of Bohr's postulates of hydrogen atom, Bohr's theory of hydrogen atom. Then we shall have its mathematical approach, the different energy levels, and the related spectral series in the order L, B, P, BP. That means the Lyman series, the Balmer series, the Paschen series, the Brackett series, and the Pfund series. And after studying these, we shall move towards different spectral series of hydrogen atom and their related wavelengths. Then some numerical aspects of these spectral series and how we can find the wavelength of a certain special spectral line belonging to a particular series. Then we shall study about wave model. Then we are to go through excitation energy and ionization energy, and thereby go towards deep hypothesis, and then end the chapter with some numerical problems. So let us start from the very beginning, which is atoms and the general concepts surrounding it. What are atoms? Atoms are very small particles. They, according to Lord John Dalton, they were small and indivisible particles, but later on it was discovered that atoms can be divided. So they are small and invisible particles. They are called atoms. They are spheres of radius with an order of 1 angstrom, that is 10 to the minus 10 meter, and these are some spheres in which the entire mass is uniformly distributed and negatively charged electrons are revolving around the nucleus, the central point. So when scientists like Thomson came forward with an atom model, it was curiously judged, it was looked at with much curiosity, because it was the first model of the type, it was the first model of atom. According to him, an atom consisted of positively charged matter and also the negatively charged matter, and these two type of matters were uniformly embedded like plums in a pudding, for which this model was called a plum pudding model. And this model, although started the journey, it could not explain everything. For example, scattering of alpha particles through thin foils could not be explained through this model of atom. So this model was discarded. The next to Thomson was Rutherford. He came with a new model that was called Rutherford's model of an atom, and it had some assumptions. I am reading out the first 4 assumptions. The first one was about the size of the atom and the spacing. Atoms consist of a small central core. It was called the atomic nucleus. In this nucleus, the whole of the mass and the positive charge was concentrated at that point. The second point was about the size of nucleus, and according to the other four, size of the nuclear size was much smaller than the atomic size. That means if the whole of the nucleus is regarded at a small island, then the earth will make the atom. Means it is a very small point. Even if on the world map the size of the island cannot be traced. Similarly, inside the whole atomic volume, the nucleus was spaced at a very small portion, and that's why the atom should have very large empty space. The third assumption was the nucleus was surrounded by electrons, means the electrons surrounded, the electrons came roundabout way and they traveled around it, around the nucleus. The atom was electrically neutral because of the presence of two different kind of charges, the positively charged nucleus and the negatively charged electron surrounding it. The last assumption was the fourth assumption, in which he said that the electrons revolve around the nucleus and the centripetal force of attraction was just provided by the electrostatic force that existed between the positive charges of the nucleus and the negatively charged electrons surrounding it. And after the assumptions of this model, and he had an experiment, it is called the gold foil experiment, in which there were sources of alpha particles placed inside a lead chamber, as you see in this box, brown box, and from which the alpha particles were scattered and they were made to bombard, they were made to hit on a thin gold foil. And what was the observation? The observation was that a very few of the rays passed through without any difficulty. Most of the alpha particles, the rays, passed through it. A very few of them were deflected, and still a very few were deflected, making 90 degree. And most, the smallest portion of these rays were found to come back. So when alpha particle, which is, you know, that 2 helium 4, that means 2 units of positive charge and 4 units of mass, when such a heavy mass is deflected, then this should be having a nucleus with a very massive body, because a massive body can return a massive thing. Similarly, since a positively charged alpha ray is getting deflected, this nucleus should have positive charges. So he inferred that the conclusion according to him was that the nucleus contained a large positive charge, large amount of positive charge, and a large mass too. So nucleus was massive and positively charged. So after this experiment, what were the results? What were the summaries? An atom consists of a small and massive central core. It contains the entire positive charge and almost all the mass of the nucleus. Why we say that it is all the mass? Because we know that electrons are very light particles, and counting the mass of the electrons should be lapworthy. So discarding the mass of the electrons, almost all the mass of the atom was concentrated at this core called nucleus. The second experimental result was the nucleus occupied a very small space as compared to the size of atom. That's why the major alpha rays passed through the gold foil. Third point, the atom was surrounded by a suitable number of electrons so that the negative charge balanced the positive charge, so that the atom as a whole became electrically neutral. And the fourth point was about the revolution of electrons around the nucleus, and that was done in different orbits, different distances from the nucleus, like the planets that move around the sun in our solar system. The fifth experiment was the centripetal force required for a revolution. We know that whenever we have to revolve something, it must need a centripetal force. And where will that centripetal force come from? It was coming from the tiny electrons that were revolving around the nucleus. So that there was an electrostatic attraction, the Coulomb forces that existed between the positively charged nucleus and the negatively charged electrons, and that was the cause of this motion. So after this experiment, he had some drawbacks too. The experiment could not confirm everything. So what were the drawbacks? The drawbacks were that it could not fully explain the stability of an atom, and it was also unable to explain line spectrum of a hydrogen atom. What is stability of atom? You know, if we have already studied in our electricity chapters on electricity that whenever a charged particle revolves, it creates a magnetic field and it spends some energy, it loses some energy. If the charged particle like electrons would go on revolving around the nucleus, then they must emit some radiations. That magnetic energy will be some radiations, and those radiations will gradually decrease the energy level, that means the kinetic energy of the electron. That's why it will go on decreasing its radius, it will have a spiral motion and finally fall into the nucleus. But such things do not occur. Today we see the universe around us, the matter is around us, the atoms inside them, the atoms are existing, they do not collapse. So atoms do not collapse. This tells that the electrons are not moving in circular orbits at any distance. There must be some rule behind their existence around the nucleus. And the line spectrum of hydrogen atom, which gave us the different type of explanations of wavelengths that are contained in the radiations, could not be explained from this model. So it had to be modified by the next great scientist, Niels Bohr, who modified this approach and found the necessary changes that could happen so that this model can be fruitful. So Bohr's model of a hydrogen atom contained everything that we needed to be explained, and that was the better one than this. So in the next shot we are going to start from that Bohr's atom model, the mathematical approaches, the numerical problems, and till that time let us put a comma here. Watch this video. Thank you. Bye.